what is the domain of this function? This is the equation, and this is the graph of the equation. So let's make a table of it. Now you can make the table from the graph or the equation. I think the table is a little bit easier, personally, to do it from the graph. So there's a dot right there. That dot is 1, 0. So 1, 0. All right? And then 2, well, at 2, isn't that 2, 1? Now you might wonder, why don't we have a value here? I have no value at 0. Why do I have no value at 0? Why is there an issue there? Well, let's think about that. If we go up to the top and find f of 0, isn't that saying just take 0 minus 1? I put 0 for x. See, I put 0 for x. And 0 minus 1, doesn't that give us the square root of negative 1, which isn't that I? Which, isn't that really not possible? Isn't there no value for 0? But isn't that why there's no graph there? There's no graph at 0 because it's not possible to graph at 0, because they're imaginary. So this graph starts at 1 and goes to the right. It doesn't have any values over here. And that's purposeful, because anything over here is imaginary. So what is the word domain? Domain is what x values am I allowed to put in my function. And if you look at the graph, can you tell the graph starts here at 1 and goes to the right? See how there's no x values left of 1? So if we look at this graph, you should easily tell my domain are x values larger than or equal to 1. That is my domain from the graph. All right? Because there's nothing over here, but there is a value at 1. Now, another notation you could write is this. You could also write it as 1 to infinity. Both those notations are fine. You will find we'll do this notation more often when it comes to radicals. These are both notations for your domain, your x values that are possible. Now the question is, if I didn't have my graph, how would you find your domain? How do you figure out your domain if all they had is the equation? And here's what you want to think about. What you want to think about to find your domain if all you have is the function is this. If I look inside of here, shouldn't what's inside, the x minus 1, have to be larger than 0? Otherwise, won't it be imaginary? Let's think about that. If what's inside, doesn't it have to be bigger than or equal to 0? Otherwise, it'd be imaginary. Otherwise, it'd create this not possible issue. So if I just take the inside and make it bigger than or equal to 0, could I solve this and get that? Watch this. If I simply add 1 to both sides, x is greater than or equal to 1. Do you see how this is the same as that? Which, from the picture, that was really easy. But from the equation, what if we have an equation? We have to know how to calculate the domain, the values that we're going to be putting in our table. Do you see how this table started at 0, and we're going to go to the right? The domain allows us to see what values can we put in a table, so we don't make mistakes and put in ones like this that aren't possible. So before we do any problem, we want to think, what is the domain? Because a radical has an issue with domain. You cannot put numbers in that will create negatives inside. You cannot get a negative inside the square root. So you have to stop and think, what values do I want to choose and put into this?